Welcome. Welcome to TechEd in Amsterdam. Welcome back. Who's been in Berlin, by the way? The TechEd that was 1.5 years ago? Oh, quite a few. Okay, cool. Who's been in Amsterdam at TechEd, like a couple of years ago? Wow, even more. Huh. So you didn't like Berlin? It's the wrong place to be? Oh, interesting. So you know that there are 2 TFS sessions in parallel. I don't know why, but they are. So if you love Windows Azure, you know that cloudy thing, it's in the other room. If you think real software development is more interesting, you can stay in this room. If you like both, you have to watch the other recording. I mean, this is possible as well, right? That's the good news. So I want to talk with you about quality and quality assurance, QA. The problem about quality in software is, how do you actually measure quality? If you want to automatically ensure something, you have to know what to look for. How do you do that today? Do you do automated quality assurance at all? Who does automated quality assurance? Okay, we have a problem. We can solve that. It's good that you're here. It's the first step. Who does it manually? Who has testers actually clicking through the software? Dedicated, maybe, testers? Quite a few. Could be more. Okay, good. It's a good start. So what I want to give you in this talk at the end is a checklist of things you can follow, small steps that you can do to do more and more and more and more automated testing until you have a fully automated lab of virtual machines starting, stopping, doing automated testing and everything, and you don't go to work except you get an email that something's wrong. That's almost the goal, right? Maybe not something you will have tomorrow, but we're working on that. We have small steps, and this is the ultimate guide, hopefully, on the way to that scenario. Now, one thing we need to talk about is cycle time, because how do you measure success? Before we define quality, we should talk about success, right? So when are you successful as a developer or developing company or team? What does success mean for a customer? Time to market. So basically that means it doesn't matter how long you test or how long you develop or whatever. It matters when the user actually gets it, it's installed, and it works. You have to get something that the user wants in his hands. Everything in between is just not interesting for him. If a developer says, I'm 80% done, the customer doesn't care. He cannot use that new feature, right? I mean, it's just the last bit that it's important. You have to do the full thing. So it's called cycle time. If you want to measure, somebody gives you an idea what to do, and you develop, you test, you do everything you want to document, and you push it to the user, and the user can actually use it, that's a cycle time. It starts with probably a developer checking in something new or a bug fix. And at the end, the customer will love you and is happy, hopefully. And he will only love you if it's tested and he can actually use that feature in his environment. And in between, something magically happens. It might be Scrum, it might be whatever. Hopefully, it's something efficient. And in that something in between, you have to definitely develop and test it. And now there's a fundamental problem. You all know that if you do software development, it's clever to work in small iterations, like maybe 2, 3, or maximum 4 weeks, like Scrum says with sprints, right? But if you do that, within those, let's say, 2-week sprints, you have how many days? 10 working days? 1 day is for meetings. So you have 9 days left to develop something new, to test what you have developed, and to test that the whole rest of your software is still working. How do you want to do that manually? You can't afford having hundreds of people testing the whole software. But you have to make sure that your small change hasn't broken anything on the other end of your software. And that can happen in complex systems, right? We all know that. So how to protect against that? Well, we need automation. We need something magically looking at our software and telling us if it's good or bad. And you know what? It's not that we just click a button and we get all the tests. We have to do ugly things like writing unit tests. You know, that thing that is not fun and nobody does? I think we have to do that at some point. There's no way around it, right? So measure your cycle time, less is better. And then talk about quality. Why do we have to talk about quality? Well, that's easy, because we don't have the same perception what quality actually is. If you talk with other fellow developers once what exactly quality means, you will have probably 10 different definitions between 2 of you, and you haven't tried it with a team or your company. Because there's no scientific way to measure what software quality means. I believe if I show you some code, just a few lines, some of you will say, this is good code, or this is okay. And a few others will say, well, in certain situations, this might be bad code because So code isn't good or bad. Software architecture isn't good or bad. It's sometimes better than in the other way. It sometimes smells. We like to say code can smell because it might be wrong in some cases, but it can also be right. So there's no way to say what's right or wrong. And there's no tool that will tell you what's right or wrong in your code. And that makes it so hard. And this is why I urge you to do one thing. Sit down with your team and write down what for you actually means a definition of done. When are you done? When's quality reached? What's the minimum bar you want to reach for every feature that you will develop? This is very, very important. First of all, because you have different perceptions of done. If I say something is done, I probably mean no unit tests because I don't write them. Well, I mean, of course I do write unit tests, but not always. Only if I have time, right? Like in real life. And for somebody else, it means definitely test it with unit tests. For some other guy, it means it looks beautifully and has comments in there. So we have to define what for our small team actually means done. So if your boss asks you, how far are you? You tell 80%. 80% of what? 80% of our done definition, which might include testing. It has to, actually. Do you have to document your code some specific way? Put it in your definition of done. If you think that's not worth it, don't put in your definition of done. But have a list as the minimum things that have to be done before somebody can say he's done. All the estimations you will do are now based on this list and not based on how you feel that day. You know what happens if you don't have a clear definition of done? You test depending on when you test. If it's in the beginning of a sprint or a project, you have time. The deadline is far away. You try new things, you do a little bit more testing than usual, you refactor things, you love your code because it's still clean. And then a few days before the deadline, well, there's no time for testing now, right? So quality depends on when it's tested. How do you want to explain that to a customer? Oh, no, sorry, that feature, yeah, we know, that was close to the release. Nah, not good. So we need this definition of done. And again, we're not trying to make a super perfect thing so we could ever think of tests. We're trying to find a small set of things that are really important that we want to do always as a minimum set. If we don't reach those criteria, we don't deliver this feature or this bug fix. It's not in the product then. It should be the minimum set. You can always do more if you have time, obviously, but start small maybe and have a clear definition of done. Clear means explicit. Put it on the wall. Write it down so everyone can see it. Writing it in a Word document on a SharePoint portal is nice, but nobody looks at that, really. Put it on the wall where everyone can see it. Discuss it at the end of every sprint if you want to make changes. Was it too much, our definition of done? Too many things in there? Should we enhance it because the quality is not good enough? Change the definition of done in between sprints. So what you will get out of the definition of done is constant quality. This is the good news. So at least you know this is the minimum where we are. And now estimates get really easier because we know that we're estimating the same thing. If somebody asks me as a developer, hey, how long do you think we need to develop this? I hear coding, and I give him a time that includes just coding. It does not include me understanding what he wants. It does not include me testing myself. It does not include somebody else testing. Oh, yeah, we need a setup to change. That's right. We need a deployment script. Oh, yeah, the database changed, right? That's not part of my estimate, right? It should be. When we do estimates, it should include the whole definition of done. And it's now easy because we know what is part of that done. What should be in an estimate. And now we all do the same. We include the same activities in an estimation. Of course, maybe you have enterprise standards, some naming conventions or other crazy things. Maybe the company says what operating systems to support and so on. This can be part of your definition of done to reflect those standards. By the way, who does a definition of done? Do you have one on the wall? Is there any team that defined that? A few ones? How many things do you have on that list? Is it like 30, 40, a lot? A lot? Do you test them automatically or is it like more manual? Both? Okay. Well, there are two issues, and one is it should be something you can measure. Because writing down things that you like to have in your definition of done is easy. I can think of 1,000 things that I want in my definition of done. I don't know if we have time for that, and I don't know how to measure them. Let's take my favorite example. I looked at one of those definition of dones from a team, and they said, we want to write maintainable code. That's a fair goal, isn't it? What exactly does maintainable code mean? They had it like this subjective thing on the definition of done. That meant, again, it's a matter of time. If I have a lot of time, I do a lot of refactoring and make it nicer. If I have no time, well, it's good enough. Done. So again, it was actually nothing and no improvement of their situation, because they have always written maintainable code when they had time and just skipped it when there was less time. So you have to find something that is way more measurable. So concrete rules behind it. Is that easy? No. Should you put a lot of things in there at the beginning? No. Just learn from the mistakes. Look at the output. Look what you're doing wrong right now the most and put tests in there to find those issues, or use tools that can do that. Detect code smells and do refactoring. So define your definition of done criteria, possibly with tools, possibly that they are measurable. How about another thing? Another team said the UI should look nice. It's a fair ask, again. It should be intuitively usable by the user, maybe. It's a fair ask. You want this on your definition of done, right? But how do you measure that? Actually, you can measure it. You can invite a few customers, install your new software, and ask, hey, this is the goal, what you should accomplish. We will not tell you exactly how. We think our software is self-explaining. Try it. And so if maybe 3 customers say it was good, might be enough. Maybe you need 20 for that. You can't do this in every sprint. You can't do this every day. But it would help. So what you can also do is you can have an expert, like one UI expert. He studied that. He's probably good at UIs, or we know that he is, because he works with us for a long time. Then we can ask him, like, every feature must go through him, and he must sign it off. He's now the single point of failure again, okay? But still, he's our expert on that topic. And now it's measurable because he says it's okay, and he has its standards probably. And maybe he has some rules we can actually put in our definition of done, how he knows when a UI is good or not. So a definition of done criteria, when will you be looking at those? You will always look at them once you have one feature or one bug done. So you take one requirement, feature, whatever, do coding, do testing, go through the list of done criteria, and if you fulfill all the criteria, you're done. So you do that multiple times in each iteration, in each sprint. So if you have many manual steps in here, that will cost you a lot of time. And we did not talk about testing the rest of the whole application, that it still works. Definition of done only applies to new features that you want to add. And the whole rest is still to be tested, of course. So you really want to think about automation, because there's no fun to do the same thing again and again and again. Even if it's something small like naming conventions, actually you would love to have a tool for that tells you, even better, while writing code or while checking in, this is wrong what you're doing. We agree to, like, new projects should not be added. You want a message that tells you new projects should not be added. And of course you can check that if you want. And the goal of this session is to look what can you automate using Visual Studio today. Just the built-in tools. Turn everything on that is in Visual Studio. Turn build servers on to check it on the build side. Turn lab management on to test it on real test machines. All that. And hopefully there will be something for you. And then at the end, we will look at the steps, just briefly in here. We will start with source control everything. We will go to the build server, a few things there. We will talk about testing on the build server side, and we will then go to acceptance tests in a test lab. So the first step is very important, because source control everything really means source control everything. Put everything in source control. If you have a 20 gigabyte database file, put it in source control. It doesn't hurt. You can buy a hard drive. Put it all in there. What about your database schema? Put it in there. There's actually a tool, SQL Server Database, what was the name? Data tools that you can use to check in. There's a talk here, TechEd as well. You can check in your database schema while you do a code change. Think of this as a developer. You look in the history of a code file and you see, oh, I implemented a bug fix and I changed this code file, this configuration file, and actually I changed one setting in SQL Server. And that is one change set. That's pretty neat to see as one change. But you have to version your database for that. Good. So let's switch over to my favorite demo machine. So you've seen the new UI probably. We don't have to talk about that. You probably love the new UI, right? You like it? You heard probably about the menus, the all caps menus. Did somebody tell you that there's a registry key to turn them off in the RC? Right. If you download my slides, it could be that there's a hidden slide, and that hidden slide could actually have a registry key where you can turn them off and it looks normal again. However, I cannot guarantee, as I don't work for Microsoft directly, that this will be in the final product, right? They might remove it, but right now, if you don't like the menus at all, you can switch back. So it's just a matter of downloading my slide deck, and you will see what I was talking about. There's actually one more slide that we'll show you later. There are a lot of shortcuts in here. You can use keyboard shortcuts. They are not easy to remember, but they are there. So if you want to do more keyboard-driven things, especially in the new Team Explorer, you can reach all those hubs or pages in here while using your keyboard. Good, I have a project. Of course, I spent a lot of time creating a very sophisticated demo for this. I put all my knowledge on mathematical algorithms in here, in the calculator. But at least I created a 3-tier calculator. So this calculator will not do any calculation. It will delegate it to some business logic that has a few methods. And of course, the business logic doesn't do the math here. It goes to a database or data layer, and we do the math in here. And this is all I know about mathematical operations. So far, so good. So as I said, number one is put it all in source control. I've done that already. You can see it on the small icons. It's Team Foundation Server. It's all in there. You know you can have TFS Express for free. You can have Team Foundation Server in the cloud. You can have your real Team Foundation Server, whatever you like. Just do it. And once it's in source control, you have to create a build. So the first thing after checking in, create a build process. Why? Because all the reports in TFS need a build process. It doesn't have to do any magic. Let it compile. It costs you 5 minutes to set it up. Just do it. There are a few new things in build. It's not a huge new feature set, but there are a few small and very nice little things. You can give it a name, of course. This will be the main branch, and we will do a continuous integration build at some point. You can actually not only disable, but also pause queues right now. This means that people can still order queue in new build requests, but they will not be executed because you're doing something on the build server, changing the build script right now, but they don't get lost. So they will all be replayed once you activate that build again. That's a new feature in 2012. The trigger, we will stick with manual now. We'll come back here in a few minutes. Be aware of the workspace. I still haven't figured out why the default is that the whole server gets downloaded almost. You really want to change that workspace thing. I was at a client lately, and he had like a 1-hour build process. And he showed me the files, and it was like a 20 megabyte project. How can that take 1 hour to compile? It was not C++ or anything that actually does some interesting stuff during compilation. And I found out they were just grabbing the whole Team Foundation Server source code using a get command. Because all you see in here will be downloaded to the build machine before the actual build starts. So it was actually just, they were downloading and downloading gigabytes and terabytes of data, and then build just compiled it one small project. It took 30 seconds, and then deleted it all. So they had a 1-hour build process just because of not configuring this dialog correctly. And the default is always a little bit crazy, so make sure you look at this and you at least go down to your project, or even better, you go to the folder you actually need. In my case, it's the main folder of TechEd. So we have a build default, I have a build controller and a build agent set up. You need both of them. They can be all on the same machine if you like. You should have a dedicated machine for builds. As you know, while compiling, the CPU goes up to 100%, so you really want a dedicated machine for your builds. And the more builds you do, the more dedicated machines you will probably want. The result needs to be on some network share. I have prepared one. It's VSALM drops, I think. Is that right? Yeah. It actually works. Good. And then there's a build process. The build template is the regular template that Microsoft gives you. They have updated the default template. So if you have done any changes to your default template, which is a XAML file underneath, you might reapply them now again, of course, because there's no magic that will merge two XML files for you. You have seen all the new compare tools maybe in TFS for comparing source code files, but there's no tool still for comparing XML files in a clever way. So if you have any changes that you did manually, you have to reapply them to see them here again. So the only thing that is interesting right now is the items to build parameter. The wizard is clever enough to have it selected, your solution, if there's only one. And you can now save and build your first build. Right-click, queue new build, queue, and now we have one build in the queue. Let me just add that build definition as a favorite. Add to favorites. Once it's a favorite, I can see the last results right in here in my Team Explorer window. Okay, this is just the basic stuff, and there's really no need or no good explanation why you don't do that for any small project. Even if it's just a small tool you just checked in, anything you checked in TFS, why not have a build that validates it on the server side? Even if you work only for yourself and you think, well, why do you need a build server? It's just me. It compiles on my machine. It's easy. You would think. The build server can even tell you if you forgot to check something in. So I was at a team lately and they said, well, we don't need a build server. Honestly, we're just 3 people. Why do we need a build server? Okay, let's just try. We installed it and the build said, well, 4 files are missing. Oh yeah, I added that to my folder. Oh yes, I forgot to check it in. Right. Now it's checked in, thanks to a build server. He told us that something's wrong. And you see the build server actually has color. It's nice, isn't it? It's a great moment for questions if you have any right now. So one thing you could also ask yourself is, what if a build fails? How do I know that it actually failed? So how do I get notified? And you have multiple ways how to do that. One is, of course, you look at the Team Explorer window. You probably have 2 screens, or maybe the new trend is to have a 3rd screen, I heard lately. So you probably have 3 screens, and one is for your Team Explorer, so you can see the last build results always actively. But you can, of course, get an email if you want. There's a new dialog for those project alerts where you can set up those alerts, and you get a nice email because you're not getting enough emails anyway. So you definitely want an email. If you don't want an email, there's this one hidden tool in your Start menu. It's hidden under Visual Studio 2012. Team Foundation Server Tools. It's called Build Notifications. If you haven't seen it, it's a lovely tool sitting down in your taskbar. You have to configure it once after it loaded, yeah. And then you find your collection you're working on, TechEd, this is the build, I want to be informed. If anyone starts it, not when it starts, only if it's finished. I only want the end result. And now you will get notified of builds that are either work or don't work. There's not much happening right now. At least he says it's running. Okay, we can continue while the build server is working. So once we have it in there, we really want that direct feedback. And you know that there are 2 ways to do the direct feedback, and there was a small addition in 2012. So there's continuous integration, which is the classical one. Continuous integration is very optimistic, because you check in, and then the build server is triggered, and then after some time it tells you what you checked in wasn't good, but it's checked in already. The database transaction is gone. It's in the source control database, which might be okay on a small team, right? Or if you do small iterations, you do quick fixing, that's fine. If you have a larger team, you really want to make sure that only good code is checked in and use gated check-in. So you turn it around and you say, when we check in, first go to the build server and ask it. And if the build server says it's good and does all the validation steps, then it gets checked into source control, otherwise it doesn't. There's a new mode. You can accumulate multiple check-ins into one check-in that goes to the build server. So there's only one gated check-in build that looks for multiple change sets. You can set how many change sets will be passed into a gated check-in build. And then if it works, it's fine, it gets checked in, if the whole set of change set worked. And if the whole set didn't work, then you can still go one by one and tell you who did the wrong thing. And you can set that, obviously, in here, in the trigger. Continuous integration is the optimistic one. I'll leave that on in a minute. And gated check-in is the pessimistic one. We will first ask the build server. And if you have a lot of check-ins, you can merge and build up to, let's say, 2 or 3 build requests, which means change sets in this case, together. Continuous integration. So right now what we have done takes like maybe 5 to 10 minutes on each project You should really have those and do that so you have a little bit more of a starting point here. But still, the only thing we do on the build server side is compiling. Now we need to add more sophisticated things. We need to add some kind of tests, some kind of analysis, some kind of metrics to really know what we're doing here. So how many of you are writing unit tests? Well, less than half, okay. You know that there was you remember a function, right-click, create unit test? You know that one? You don't anymore. Forget that it was there. But you can now add a unit test yourself by creating a new project, test category. There's a separate unit test project now. Give it a nice name. This name should have test in there. VB, what did I do? Well, maybe VB6 would be nice, but this, no. Let's go to real code. What was that? Oh, that was a coded UI test. So now I've shown you all the different types of tests that you can do with a new UI. Actually, there's not a big difference between the projects. You can still put a regular UI test or a coded UI test in a unit test project. It doesn't really matter. It's just a little bit. The IDE can help you better if it understands what you're doing. So now we have a few projects, and one of them is interesting. So let me delete the ones that we don't need. So unit test projects 2 is the one we're working with. You can give it nicer names than I have done right now. And you can start now. The only things like references, you have to do that manually now. This references my WinCalc main project. You might want to add the namespace here, and now you start the testing. You know that a good unit test has 3 parts. You try to arrange the things first that you need. So in our case, we want to add 2 numbers. Maybe we want to add 1 and a 9, and we expect a 10. Then you want to execute that and see how it actually behaves. So the expected value is not interesting. It's the result. We will test the business logic layer, so in the middle. And this is good, but you need to assert. You need to find out what the actual result is. There's an R equals, and actually you can even use generics here. Expected first, and then the actual result. So now we're checking that the actual result means, or it's the same as the expected one. Okay, you probably know that. You know that you really have to be careful when writing unit tests, especially your assertions. It's really hard to write a good test, and Visual Studio is not helping you here at all. You know how an empty test looks like and what the result of an empty test is in Visual Studio? An empty test is green. It passes. It's successful, yeah. Why? Well, it could have crashed. It could have been worse. I don't know. I mean, yeah, an empty test is as good as a really good test that just says 1 is equals 1. So at least we have a unit test. And now a few cool new features. You can turn on the run tests after each build, and it really means the local build. So once I compile, I immediately get my test feedback. Well, immediately means it takes a few seconds, but there's a new window. You see he's discovering the new tests right now. And once my machine is awake, we will see the one test that he discovered. Now, actually, if you have unit tests, this is pretty cool. If you don't have them, it's not that cool. If you have them, it's cool because you just change a few lines of code. The compiler runs, and all your unit tests, your static unit tests that don't need a database and stuff, run. And they're pretty fast because they're very small unit tests. They only look at your code, and they don't need any other dependencies, right? And they're pretty fast. You can run thousands of them in a few seconds. And now you really know that the code actually works because the compiler doesn't really tell you if your code works, right? So you can have that on. This is locally still before check-in. So this is the first feedback mechanism where you can get instant feedback that something you've just changed broke something else in your product because you run all the tests you have. If something goes bad, by the way, you will see it in in the list here, and the failed tests are the first ones usually. Let me write another one that fails. And now we just compile. We never say run the test. Oh, that's even worse. Yeah, I don't need a second class for this, I guess. It picks up another test. It tells me which one was the failed one. So again, it runs all, but you see the failed one is the first one. If you do any changes, now all the failed ones start first now, because they're the most likely ones to fail again. So those run first. If you have many tests, this is a good idea. And now we can fix this again to actually work. We just recompile. We never say run tests. And we get instant feedback that this is there. So we really need to do that. We need to write a small chunk of code and at least one or more unit tests to test that. Is that fun to write a unit test? Who thinks it's fun to write a unit test? Yeah, there are a few crazy guys always. That's interesting. I personally am not a fan of writing a unit test because it takes me longer because I'm not used to it. I need 4 times as much code as in lines of code than I write the actual production code. But we need to have them. There's no way around it. If you do any mistake in a critical software, that's not good. And there are enough examples. And a small unit test, it's quite easy to write if you get used to it. And then it helps you write when writing and leaving your line and compiling. It helps you discover what goes wrong. Who does test-driven development? Who tests or writes a unit test first and then writes the production code? Sometimes, a few ones, okay. I didn't know what to think about this. Before recently, I knew it now. And now I know. The thing is, if you have 2 things in life, and one activity you like a lot, and the other activity you don't, which one should you do first? Do you want to write code what you love first, and then, oh, the unit test, I can do that tomorrow. No, actually, I can do it after tomorrow. Do you want to do that? Write the test first. It's done. You get all the instant feedback. Then you just write the code. Actually, you write less code, because you only write the code to make your tests go to green. So you write less code. The chance that you do over-architecturing and add more into that thing are less. And you're doing something that you love now, because you've done the ugly part first. So test-driven is a great thing for people that have a hard time motivating themselves doing testing. And again, if you've written a test, you cannot skip the test anymore. If you write the code first, you can still say, well, we can release it without a test. Well, you can't if you started with a test. So this is good. This is less good. Luckily, we will find a way to stop this. The next step would be to actually get some kind of metrics on what we're doing here. And while I restart the service, let's talk a little bit about code coverage that is still included in the product. Stop, start. No, not the background job. Well, you never know. So there is no measure of good or bad tests. Again, an empty unit test gives you the same result as a very good or very bad test, because it could just be green. And code coverage at least helps you identify if you have gaps. So code coverage is a better name for, it's a gap analysis. It tells you there is a part that you haven't tested. I'm not sure this is a great part to test or that you should do it, but at least this is where you have gaps. And turning it on in 2010 Visual Studio was not that easy. Luckily, it's just a few clicks now. You go to Automated Tests. You click on the three dots. You go into the default test run. And there are options. And you can just say, I would love to have code coverage, actually. That's it. You need to have Visual Studio Premium for this to work on the build server, but that's it. Do we have a new status here? We don't, right? Stop. So this lets me show you a great new feature, actually. Once my Visual Studio is responding, it will open a context menu on the build itself. Any questions, by the way? What a great moment. Yes, sir. Do you need special configurations for gated check-in? Is that your question? No. All you say is not regular continuous integration on the trigger list. I want gated check-in. That's it. He does the rest. You can even do something very interesting. If you have a lot of tests, which you probably don't, but at some point it takes longer. You have some tools to check your naming conventions, and you do some crazy stuff. And it takes longer and longer, but you still want that quick feedback to the developer. So what you can do is you can have the gated check-in just with the very important tests, so that it maybe runs maximum 5 minutes and gives the developer yes and checks it in. And then after it's checked in, you trigger a continuous integration build that does maybe a 2-hour validation, and that runs on the checked-in code then. So you can have both, actually, as a combination, which is pretty neat, I think. Yes, sir? What changes have been made to the build template? I'll show you a few in a minute. Once I click on this here and say QNew build, and hopefully this will now run. Build 14 stopped, that's right. Build 15 is still thinking. So changes to the build template. There were just a few. You will, most notably, you will see in the process list under advanced, 2 things. There's one to enable MSBuild multiproc. You could do that already with a parameter. It's just now a real parameter here that you can choose, and the default is true now. So it uses multiple CPUs. And then this is also pretty interesting for specific deployments. The regular default, all the outputs of your solution are put into one folder. And now you can say you don't want this. You can have, if you have multiple solutions, for example, that's the first instance, he would put all in one folder. Now you can stop him from doing that. And you can even stop him from doing one solution output folder and let him create project output folders. Both is possible. That was a stock build. No, I want the real build. Not really running as expected. However, my notification worked. It tells me the last build was stopped by somebody. That's right. You see color in there, even better. And you can go to build details, which will just open the build page on the web portal to get a quick look into this. Compiles the web portal, opens the build definitions, and now you'll see the same result in here. One thing to note about this tool, you have that in 2010 Visual Studio already. It's not the fastest tool, and this is by default because it actually pulls the results from TFS. So I think by default, all 2.5 minutes, it looks at the build definition, says, hey, is that build done? Is it done? Is there a new result? But it's 2.5 minutes of delay at maximum. You can still tweak in the registry to go down to like check every 30 seconds, but if you have a lot of users, that creates load on your server. Yeah. So while this is thinking, let me open another instance of Visual Studio. Because luckily, I have a working version with me. And I think it's this one. This is not the working version. So this now heavily depends on the internet. As you know, that works pretty good here. And while that downloads, Just one thing, the default that I'm using here is the new local workspaces feature. That means all the files that lie on my hard drive, there's no read-only flag anymore. They're just detected once I change them and checked in. So it's a behavior you might know from other source control systems. So there's no explicit files or have a read-only flag that you have to remove or something. You can work perfectly online with that, offline I mean, and then go online again. And things will be just fine. So let me show you a solution I prepared with the exact same code we just saw. The cool thing now is I have a few more unit tests once I do my build. And this is the button, Run Tests After Each Build, that you can now click here or the menu above. So new in the build report, you can actually see who triggered that build, what was the request, and what was the response. Because now, where you can accumulate certain build types, like those 3 builds were requested, but still we will only do one gated check and build. There's a difference between somebody requested a build and we actually do one build. And so we will see there's a request summary on this. See the request summary. So there was one request, request 13, and the answer is this build. And if I have multiple requests accumulated, I would see multiple requests here. You, of course, still see the results of your compilation, of your testing, of your code coverage. This is now what I turned on. There is a small bug in here. Just ignore the first few lines. So you actually only see the bottom part. So you will see in this case that my tests are quite good, 78% code coverage. I even used 98% or tested 98% of my tests itself. Nice. There was one change set. Good. So this basically looks like in 2010, just with the request additions that you see here. Okay, back to the definition that I just showed you. This is the exact same thing we just looked into. So back again, step 1, get everything into source control. Step 2, create a build definition. Step 3, turn on code coverage. Now it's just a single click, but you need Visual Studio Premium for that. And now add tests, whatever you have as tests. Unit test, great. Code coverage, great. Code analysis, do it. Whatever you have, turn it on. If you have tests with NUnit or stuff, you can just include them. They will work as well. You see the new Visual Studio Test Runner, the option. That's actually the new thing. It will automatically detect other tests. I actually downloaded and tried one because I downloaded XUnit. It's a new testing framework, and you can actually see I have a few XUnit tests here on the left running. And if you look into the XUnit code, it's a little bit different than the NUnit or MS test code. So it's importing XUnit, and you have, well, this is pretty similar though, but the more interesting part is here, for example, for exception handling, you can actually mark the line of code that you expect to fail with a certain exception. In MS Test, you could only say the whole thing has to fail with a certain exception. Now you can go on that. This line should have the exception, not another line. If you're testing some generic exceptions, that makes a lot of sense. So this is one feature that XUnit has. So XUnit is just part of my project. It's actually even part of the same project. If you look here, the XUnit tests are just another class in the same set of unit tests in the same project. This is Microsoft Test. This is XUnit. They both run together. So what have I done to make that possible on the build server? I had to do something, and I had to go to Team Explorer, go up, go to source control. I really have to learn the new keyboard shortcuts. Go to custom assemblies. So I created a custom assemblies folder, and I checked in 2 files I got directly from the XUnit website, and 1 file that is the adapter from Microsoft. So those three files together allow me to do XUnit execution on the build server. And then you have to make sure that the build server knows about this. Build controller, go to my hosted build in this case, and the hosted build, by the way, is this one here. and he uses that folder, it gets downloaded, and he will automatically look for adapters if he needs one. So you can mix and match. That's pretty neat. Good. So what more can you do on testing? We have seen unit tests, regular unit tests, good. We have seen other kinds of unit tests, XUnit, nice. We can add more. We can, for example, add, I had an interesting example in here, or let me just add one. Let me grab one of those basic tests. The problem with writing unit tests is that you need a lot of them to actually test the method in a good way. If you look at this add test, I'm just testing one scenario, so one set of input values against one expected output, and I declare this method as tested. Code coverage will tell you this is tested because we read once through the method, right? Those lines were hit by the execution engine. So what you want to do actually is increase the number of test cases here, and obviously not by copying code and having like thousands of unit tests here. You want to import values from somewhere else. So maybe you have some business analyst and he can provide you something like Excel or maybe a CSV file or a database. So you get a few real-life testing data out of that. And you use this input data and you just replace the hard-coded values here. Wouldn't that be nice? So how about we could just replace this and say this is the current row and this is the first column of some file, and this will be the second column, and this will be the third column. Now you need a file. Okay, we can do that. This is my favorite test preparation tool. So let's say we have number A, we have number B, and we have expected result. So 1 and 2 should be 3, and 2 and 2 should be 4. And 2 and 3 and 2 should be 5. So 3 test values. Save this. And the easiest thing, I think, would be a CSV file. So what does CSV stand for? Comma separated something? I have no clue what he's asking, but I'm just pressing the buttons. This is intuitive. Now we have that file. So what did you say what CSV stands for? Comma separated files. It actually works. Nice. Actually depends on the operating system that you use if you get commas or other characters here. So let's import this. Test data CSV. There it is. So to make this work, you need 2 things. You need a test context. Luckily, I prepared a test context. You have to write that yourself. This is a test context. It's just a public field that gets set automatically, a public property that gets set by Visual Studio on runtime. So you will get some context information. Like, for example, in a unit test that will have data, you can actually say, this is a test context, and there is a data row that I want to talk to. And we will convert the output to int32. Good. Now we have to import the data. We do this with a second attribute. Luckily, I prepared that already. There was a nice dialog in Visual Studio 2010 that's gone, but you can use a lovely attribute now. So first we're telling it that we need a file, which is the test data CSV. This is important. We need to select that this file will be part of the build. It should be compiled as content, and it should definitely be copied into the output folder. So it's there, copy always or copy newer. The data source itself is a CSV file. It resides in my folder, test data. And when you open it, there is only one page, so there's nothing to specify, no table names or anything for CSV. Sequential means we will always execute all the data in that file, right? So if we have now 3 lines, there will be 3 unit test runs of the same test. But the question is, do we do it sequentially? First line, second line, third row? Or do we go like a random, but still every line gets executed just once, exactly once? And now if I just compile, my unit test runner on the left should actually see the new test and execute it. Build started, build thinking, build done. He's discovering new tests. And the first one he ran was the new one because he discovered this is a new test. Probably this is the most interesting to you. We run that first. And if you want to look into the results, you see the results here at the bottom. See the source line, you see how long it took. Looks good. So from the Test Explorer, you can do a few interesting things. You can drill into the error message. We don't have one, luckily, now. We can drill into the code coverage details. You can see if it's a data-driven test. You can see all the executions that happened with the rows where they happened. And code coverage is now just a right-click on a test, and then it dynamically looks for the code coverage and tells you the results, hopefully. I did say analyze, didn't I? Oh, there it is. And it still looks quite the same, and you can go down and see where your testing gaps from your test strategy are. Okay, that's quite nice, I think. There are worse things. Now, so you really want to do this code and tests together as one thing, as one atomic operation. So whenever you change code, you write or edit a unit test you already have, so that all your check-ins basically are a little bit of code and a little bit of unit test, and this is one thing. If you do that, the tools will help you a lot. And of course, it will help you for the whole process, because you definitely know you tune something here, nothing's broken on the other side. But this is all very functional, low-level unit testing that I'm showing you. This is not a scenario integration test, and this is not too intelligent. It's just really looking at one method and trying to find out if it works or not. You can, of course, introduce your own clever tests now, and this is where the fun starts. I mean, a unit test is code, whatever you want to execute. Now, you have to come up with a great idea first, but I think you will have enough ideas. Let's think about things like, in our team, when new dialogues are created, people usually forget to set resizable to true. Or people tend to forget to add tooltips to buttons, and actually we want tooltips on every button in our software. Why not write a unit test for something like that? Wouldn't that be nice? It's just a unit test. You can do that. Why not? And guess what? I prepared something that you can download then. See the some more unit tests class. So what I do here at first is I try to find out where the assembly is that we're testing. So I grab one of the classes, my business logic, I get the assembly class, and then I get, using reflection, I get all the forms out of that assembly. So I scan the whole assembly for all types, and I filter out, is it a class and is it a subclass of a form? Then I probably want to have it. So now you have a list of all the forms. And now you can actually create those forms. So I'm dynamically creating all the forms that we have in the project, because once it's created, it runs its constructor, it's run the load, it initialized controls will be executed, all the stuff you do in code. And then I look into the final object, and in this case, I look for the font size. You know that starting with Windows Vista, the default font is not the old one anymore, it's now Sego UI with 9 point. So I now check that all my dialogues have the new font, and if not, I throw a unit test error. So this is one unit test scanning all my forms for consistency. That's a great idea. You can have other ideas, just add them. And you don't have to come up with great ideas, just wait until something goes wrong, identify what you do wrong most in your team, and then write the fitting unit test to make sure nobody introduces the same error again. So adding some more interesting unit tests. So unit testing isn't always that easy, as I showed you. Sometimes there are more interesting cases. For example, I have a greeting class. So my boss made me implement a greeting class. And the greeting class is used when the software starts, because always if it's the first day of the year, my software says Happy New Year. I don't know, the boss said he needs that because it's nice for the client to have a nice greeting in there. So I wrote this class. It's a static class. It has one method. Is it the first day of the year? And if yes, I give it a true. If no, no. And now, as a developer on the team, I need to write a unit test. Now, this is not that easy because we have a date now in there. So once you get information from a class, like from the .NET Framework itself, that is changing or coming from another source, it's not as easy as it was to write a unit test. Of course, you could say, yeah, we could create our own datetime class and make an interface in between and have a testable datetime then. But it costs a lot of time. So luckily, there's a way to fake the date for such a unit test. That's pretty neat. So what you have to do is the following. You go to the reference where the class you want to fake is defined. In our case, this is defined in System or MS Core Lib. So System and MS Core Lib are not shown separately anymore in the references. It's basically one thing. And in there, you will find the definition of the datetime class. You right-click this, and you say Add Fakes Assembly. So it will actually generate an assembly that looks almost like the initial assembly, just with fake types that do actually nothing. Once you click that, you will get this one here, an MS Core Lib and a System 4000 fakes assembly. I'm using .NET Framework 4.0 here. And now you can just program against this fake thing. Let me show you how. Let's test the greetings. So we need a value. So let's do the 3 A's. Arrange. So we will need some datetime. Let's say we test if it's the first day of the year. That means 2012-11. And the expected result is that if we pass this in, I would like this to be the first day of the year. Yeah, it should pass. Now it's the act phase, so we go to the greetings class. It's static, actually, greetings. It's even worse that it's static, so I can't just initiate a new object or do any crazy stuff. It's a really static thing, but still the fakes assembly doesn't care if it's static or not. And then we assert the result, which means make sure that our equals are equal type of bool. The expected is the actual result. We don't have a result yet. Like that. So this is a great unit test, but as you know, today is not the first day of the year, so it will not pass. So what can I do? I added my fakes assembly, as you know. And now I'm adding even more. I'm adding new. I go to the system namespace, and look at this. System now has a .fakes. And in that .fakes namespace, you will find a few interesting classes that will help us to work around this. And I'm pretty sure I arranged that already. Let me remove that for a second and replace that with some code snippet. Look at this new code snippet. It's basically the same code. We still assert true if the result of greetings is first day of the year. We directly go to the greetings class. But the new element here is a using statement with a shims context. The shims context comes from the Microsoft Quality Tools testing fakes assembly. So we define for this context in here, whenever somebody calls the datetime class, we use the shim datetime, which comes out of fakes. When somebody calls the datetime class and he says now, and he wants to get that value, give him actually this value. So now we're testing today is the first day of the year. And does it then return true? Where's my test explorer? Stick it to the window. It does. And now we can also make a false test. If it's the second day of a year, the false test, I expect this to return false. compile. Let's see what happens. And it runs as well. So now we just, although we just used the static class, and we wanted to test the static class that used another .NET Framework class, we could still do it by using that fakes assembly and just redirecting the calls to datetime to our own value, overriding that value. So that makes it quite easy if you have things like SMTP client classes or stuff like that from the framework, and you want to try to test it somehow. That will be your helper, fakes. Good. As you know, on the build side of things, which is not really drawing as expected, there it is. Still, all the tests automatically run that you have in your solution. You know that this is a special algorithm Microsoft created. If you have never used Team Build, you will be maybe surprised that once you check in your first unit test, it automatically gets executed. I'm sure they needed a lot of experts for this great algorithm. They're looking for star test star.dll in all your projects. So once you have test in your test project name, that's very important. It will automatically get picked up, and you don't have to specify anything. You can still go there and use some more criteria like categories or tell them which DLLs contain the test, but you don't have to as long as you just have test in the name. It will just automatically work for you. And this is good. So now where we have all those tests, the build server runs them all. And the cool thing about this is we created this data-driven test. You remember the test where we used the CSV file? This has a lot of advantages. So instead of writing maybe 30 or 40 unit tests, I just wrote one test. I attached a data source attribute and just grabbing data out of it. So this saves a lot of time for me writing. I have less code I have to maintain. And that CSV file actually could be maintained by somebody else, somebody from the business requirements side of things. Some business analyst, some tester. I, as a developer, don't have to touch the test just because we have new test values. Somebody else can do that. Maybe we can even get a copy of real-life data out of our real production system. Maybe some things are stripped off, but maybe we can get a set of real data that we can just import into unit tests and see if still all our assumptions are true, or if the real production system has some other crazy things in there. And then, of course, at some point, we need things like static code analysis or some rules like naming conventions. You know that Microsoft has that lovely tool, code analysis, which is now, by the way, also in Professional Visual Studio. And what I've defined here is, instead of choosing one of the default rule sets that we have here, you can define your own rule set. You see that my team has an own rule set. So you can just add a new rule set to the whole solution. It's called code analysis rule set. And you can then choose which of the rules you think are important for your team. This is, again, something you can do as part of a definition of done. And that's important because not all of the rules are really meant for you. Some are really interesting, and some are really just for people who develop on the .NET Framework team, you would assume. It's nothing that you should care about. You should grab those ones that you think are important, click them, check them, and save this as your definition file. So I think the Microsoft naming conventions, I'm using the same one, so I think I can go with those. They should only be a warning, not an error. And let's give this a name. This is the TechEd coding rules. We save the file as rule set 1. It's a great name. And now I can choose the rule set 1 as my new default rule set and check this in. So the default on the build server is, if you have a rule set defined, it will be executed if you also execute it locally. So if your project file has yes execute code analysis, it will be done on the server as well. If you turn it off locally, it will not be done on the server by default. And this is the process parameter that controls it. That will pop up in a second. Advanced. Where's it gone? Oh, there it is. Perform code analysis as configured. You can also say, no, I want to control this actually on the server side of things. It will always be on. We will always do code analysis. No matter if you do it locally on your machine, we'll always run it on the server. And if you want to go further, you could even say which one has to be executed. And you can hard code this as a parameter in this field down here. Let me just start with a few parameters here. So you can say that code analysis rule set that we just created has to be the one. You can also say ugly things for the compiler here, like, by the way, and your team will love you if you do that. For example, all compiler warnings are now errors on the build process. If your team says this is part of your definition of done, put it in here. If not, leave it out. So you can have a lot of interesting code snippets and parameters in here. So the one I was talking about right now was P code analysis. You have to use the rule set, which is named ... rule set 1 rule set. This is now the new default one that we set up for our team. And now he will make sure that this one is used right after the check-in is done. Isn't that checked in yet? Where's my check-in happening? Go back, go to pending changes. No, it's checked in already. It's probably just the status. What if I check in again? No pending changes. How would I close that window? How would I close this? No, fine. I know it's checked in, that's enough. Ignore the signs, it's checked in. Good, so now we have the build server that also does code analysis, and hopefully he will tell us in a minute what that actually meant and how that worked once he's done compiling. He's still doing a few things. He's executing all my unit tests. He's reading the CSV files. I had a few other ones. He's running XUnit. He's checking all my forms if they're using the correct font. And now if you even want to add more, you can do an architectural validation if you have Visual Studio Ultimate. So if you have one guy on your team that does the architecture of your code, he can draw that as a layer diagram, put it on the server. It will be part of the build process then. I'll show you that in a second. And then you can turn on gated check-in, which means all the rules we just defined, all those unit tests, all the code analysis, all that stuff, will be part of every check-in and will be checked before the actual check-in or commit in version control happens. Okay, this worked so far. Let's look at the test results. Looks good. I'm quite happy with this. So let's go to the architecture part of the world. So there's a model project, a modeling project that you can add. In this modeling project, you can do cool things like add a layer diagram. Layers are pretty cool. You can draw your favorite intended architecture. It doesn't have to be like your code looks, but what you actually want it to look. So just use layers and make it nice looking. This is a brilliant architecture. I hope you can see that it should be a 3-layered architecture with those are the dependencies that I allow. And you can also use some helper classes from each of those layers. So this is front-end business logic, data logic. This is helpers, whatever, common core. And now you can even add some more stuff to it. So this is your intended architecture. You can add comments if you want, but I think that's enough now. Intended. Now you have to do a connection to your code. You can do this on different levels, on namespaces, on assemblies, or even on classes. In my case, I need to use classes because we don't have too many code levels here. So let's just grab a few classes. So let's say the business logic is here, the data logic is at the end, the greetings class is I don't care where it is, and the main form is actually something from the front end. So you do a mapping. You see those numbers here represent how many things you actually mapped. And usually you don't use classes, right? You would use namespace or a whole assembly and say this is in that layer. And you can now validate it by right-clicking and say validate my architecture. And in this case, I don't think we have done anything, we have broken anything. So let's do the following. I will check in and check this in. Now with new layer diagram. Check-in is running. And on the server side, I will go to my build. And I will tell the build to do the architectural validation on the build server itself. It requires a Visual Studio Premium on the build server, and Ultimate on the build server even. And you just need to check this small checkbox here and tell him to do architecture analysis. This is the checkbox. See it here? It's p validate architecture equals true. Yes, you will find this documented on the MSDN library. The problem is you will not find where it's documented on the MSDN library, so that would be too easy. But it's a part of my slide deck. You have a references slide at the end, and that should help. And now we will even change that and go to trigger gated check-in. Because now we have everything turned on that it's possible in Visual Studio out of the box. Now we can go to the code and actually play around with it. So I might be a new developer, a new young developer on this team. So I decide, how about I do a small change? Because there's a shortcut we can use. We don't have to use the business logic. We can actually directly go to the data layer, which is obviously not allowed on this one occasion. I assume that all my unit tests are still running correctly because I haven't destroyed anything in the code. It's still working code, right? So the unit tests will say it works. The compilers say it works. It's just a logical thing. You're creating some waste that we don't want. It's a different dependency than what we intended. And this creates an ugly architecture maybe, but it still looks good. So now I say check in. I found a shortcut. Yay. Check in. And now TFS says, wait, wait, wait. We are guarding this particular folder on the TFS side with a gated check-in. So it goes to the build server first. Click here to watch the status of the validation build. So you can watch it actually while we check it. And it's still not part of the source control repository until this build hasn't finished. There was one request and one response. And the response is still the build server running. So while the build server runs, we will be back in a second. Let's go back to the slide deck and look at the step-by-step guide to more quality. So source control everything. Not always easy if you have databases, but do it. Automated build takes 5 minutes. Continuous integration is just one checkbox in TFS. If you want it more pessimistic, use the gated check-in. Step 4 is the most interesting right now because do everything you can do with build verification. Add unit tests. Add clever unit tests. Use code coverage to find where you don't have unit tests. Add a data-driven unit test to have real data. Use the layer diagram if you have at least one ultimate version. Use the code analysis to have your rules that you defined as part of your definition of done in there. And at the end, just try to automate your definition of done. And while you write your definition of done, just think of what you can automate easily because this is what you really, really want. There's a next step. And this is the most interesting one if you go further is how can we now test those applications in a real context, right? We need a test lab, maybe with physical, maybe with virtual machines. We want to have our software deployed. We want to run automated tests first on those labs, and then have manual testers look at them and do the actual testing. The new feature in TFS 2012 lab management is that you don't need to have a whole Hyper-V environment if you do the testing. You will still get more features, and it's still this more sophisticated thing. But if you just want to save time and you want one virtual machine with your software to be installed and be ready every morning, so the build server would build that environment up each night and present you with a ready-to-use installed environment of your software and say, hey, now you can do the manual test, everything was okay. That's now just a few clicks away. It's called a standard environment. You need Microsoft Test Manager to set that up. You just point to any machine where you have admin access on it. It can be a virtual machine, it can be a physical machine. He actually injects a test agent that will do the deployment and running of code. The only thing you do not get, he does no automatic snapshotting
no starting and shutting down of VMs because he doesn't know it's a VM. He just uses an environment that you prepared with whatever technology, and you say, there it is, and I have all the rights, all the permissions. And then we just magically work. This is a really cool thing. If you want to see that in action, I'm glad to show you at the ALM booth in the Texpo area today or tomorrow. Tomorrow, the whole afternoon, I'm on duty tomorrow if you want to talk to me about or see it in action. Our build server responded. You see that my check-in validation build got rejected for 2 reasons. He says, even twice you destroyed the intended architecture because you tried to call from a layer called front end to a layer called data layer. This is not an allowed call. You try to call the data layer method, which is the constructor, and you try to call the add method. So 2 mistakes where you didn't watch out for our architecture. You see the warnings below. This is the code analysis that we just turned on with the rule set 1. So you get those interesting suggestions how you rename your code because I used the Microsoft naming conventions. Especially I like things like the spell checker is in there. So they actually do a spell check of your names, the parameter names. Oh, this is also a good one. In your business logic add method, please consider using a more meaningful name than parameter name A. Yeah, he's probably right. And still many developers will use Z or whatever as a variable name. So it's really easy to set up what you have just seen. You have a checklist. You can follow this checklist. I will meet you at next TechEd. I will check that you have done the first 4 steps. And we will talk about the 5th step and how we can proceed there. If you want to talk about the 5th step right now, let's go to the LM booth and do it there. I have just a few more slides before we go to lunch together. And I hope they are also useful for you. So those are the keyboard shortcuts. I promised you to show them so you can directly go into the pending check-ins or pending changes or the build window. So I was clicking all the time in the Team Explorer, going out, going in, going to a link, going back to home. You can automate that using keyboards. I think it's way easier to do that. You have a few reports on how well you are doing in TFS with the definition of done. So this is one report I really like, because on this report you see on the left side all your build definitions, and on the top you see the dates from the last, I think it's 1.5 weeks. And the cool thing is you get a color of the last build for that day, for that build definition. So if you get red, you had a compile error and stuff like that. The interesting part of this diagram is you will never get green if you just have a compiling build. Because what does a compiler do? It doesn't really tell you the code is good, right? So for a build that successfully compiled but had no tests, you get yellow, that ugly yellow over there. So then you say, well, I can add a unit test, right? Unit test assert 1 equals 1. Now you have a unit test. What do you get? You get that very limey, light green thing because you really have a unit test, but your code coverage value says you have many gaps in your unit testing. And once you're over 70%, so only 30% gaps, then you get a real solid green that you know. So this is a psychological thing because developers hate it if things are not green. If you see something red like a build server, you want to fix it. I have seen, so developers who for the first time have a build server, you know what they do? They run it once, they see it green, and they click on run again. It's the same code. Nothing has changed. But you just want to see the effect of, again, a green light. It's just so cool, right? So this is really some psychological way how Microsoft tries to tell you, you need more tests. You wanted to do it. You will never get green here. And of course, you have more reports if you want to have them. In my slide deck, you will find the checklist, a few references, all the things I clicked today. There are actually blog posts around this, so you can find it in the slide deck. I put all the books that are out or coming out for 2012 Team Foundation Server also at the end of the slide deck, so a few references for you. So please don't forget, while at lunch you can start talking about it. Create a definition of done. I will check the next year. Try to automate as much as possible of that definition of done. And try to measure your success. Remember, your success was how long does it take, developer checks in, and the user has the fix or the new feature in his hands. That's the only important thing that counts for a customer. Enjoy TechEd. And if you want to talk to me about the rest, come to me to the Visual Studio ALM booth. Thank you very much.